This is GCSE Further Maths. We're doing mechanics and we're just starting chapter 2, Newton's laws. Just take a read through what it has to say. The first law, body continues in a state of rest or uniform motion in a straight line unless it is acted upon by an external force. The second law, the acceleration is proportional to the external force that acts on an object. This is summarised by F equals ma, where F is the external resultant force, m is the mass of the object, and a is the acceleration. The third law states that every action has an equal and opposite reaction. Most of our work is going to be on F equals ma this chapter. However, the other laws will come into it and we'll mention them then as we go. So let's take a look at this one. A force of 42 newtons causes an object to accelerate at 0.7. Find the mass of the object. We want to try and get into the way and used to drawing force diagrams showing what forces then we have acting on it. So we have a force F, which is 42 newtons. We have a normal reaction. Again, we'll talk about that a little bit later on. And then acting down on this force is mg. That's the mass times gravity. The acceleration we normally symbolise with a wee double arrow there. See the two arrows? And in this case then it's 0.7. So we would use F equals ma. The calculation is very straightforward, to be honest. 42 equals mass times 0.7, and that means then the mass must be 60 kilograms. Example 2. Find the force needed to accelerate a mass of 10 kilograms from 3 meters per second to 11 meters per second in 4 seconds. Find also the distance travelled. Okay, let's get a wee diagram drawn. So this is a 10 kilogram mass, which means there's mg, and in this case it's 10. So 10g is actually down this way. Normal reaction, you can see nothing because of my hand here, so we'll try and move it down, maybe that's a little bit better. That's R, and then my force is acting like this, and the acceleration we don't actually know at the minute, so we're going to write A meters per second squared. We're going to work out A using UVAS because we have the information for it, but we'll start with our F equals ma here. Or F then equals 10. Okay, so let's find out what we know then. Let's see if we can work out our A. U, V, A, S, and T. U is 3 meters per second. Our V is 11 meters per second. The acceleration we're trying to work out. Yes, we don't know, and the time then is 4 seconds. So in this case we would use V equals U plus AT. 11 equals 3 plus 4A, with the time being 4 there obviously, so that means 4A equals 8 and our A equals 2. Therefore, take this over here. F equals 10A, F equals 10 times 2, and F then equals 20 newtons. The other thing we've also been work out is the distance travelled. So for this we're going to use S equals a half U plus V upon T. S equals a half 3 plus 11. And our time then is 4. S equals 3 plus 11 is 14 divided by 2, it's 7. So 7 times 4. And then S is going to be 28 meters.